Guys, in this video we are going to see how to derive Biot Savart law. But before we do that, first of all we have to know what is the single charge, like when we have a single charged particle moving through the space, what's going to be the magnetic field? That is given by this equation. B is equal to mu naught q v cross r over 4 pi r square. Here mu naught is the permeability constant, q is the charge, and also the direction of the magnetic field is going to be depend on the velocity. Like if you point your thumb toward this velocity direction and if you curl it, you will see at this region the magnetic field is going to go inside, right? That's why we have cross right here. And Biot Savart law says if this is true for a single charged particle, then it should be true for a magnetic field caused by a small current segment. That's what we have right here. So Biot Savart proved that Biot and Savart proved that this is also true for small current segment. Now let's see how to derive the Biot Savart law equation. Now in order to do that, we are going to do the same equation. Like instead of B, we are going to put small segment B. We are going to put dB, and that's going to be equivalent to mu naught. And here we are going to take a small charge. That's going to, let's call this one dq, and that's going to be dq. And instead of, okay, let's call the dq, and then instead of v we are going to have drift velocity cross r, okay, that is divided by 4 pi r square. And then we are going to, instead of drift velocity, we are going to rearrange this one because we have to express this one in terms of current. When we talk about small current segment, we have to talk in terms of current, so we are going to replace that one. Also we have to know that dq is going to be equivalent to nq dV, right? Here n represents the number of particles per unit volume, and this q is the charge of the particles, and dV is the volume. Also you can express the volume as nq times ADL, because if you multiply cross sectional area of this small segment with the length, that's going to give you the volume, right? So nqdl. So this is also another equation for this charge dq, small charge. Now what we are going to do is we are going to replace this one and do something like here. We can, instead of this dq, we can replace this one. This is going to be nq ADL, and then we have vd cross r, okay, over 4 pi r square. Let's bring this equation right here. Let's continue here, and then instead of vd, because when we are talking about current segment, it doesn't make sense if we just talk about drift velocity, right? So we had to include current. So to include this current right here, we are going to rearrange this drift velocity, and that's going to give us I over a and q. So that's the one I'm going to replace. But when I replace, I'm going to cross multiply dl cross dr, I mean dl cross r, because the direction of the dl and the vd is going to be same, right? Direction of this one and this one is going to same, so we can cross these two, dl and r, right? Now let's continue here. Mu naught, and then we have nq ADL. dl, I'm going to cross this one with r, dl cross r, and then instead of drift velocity, I'm going to replace this one, I over a and q. So I will be on top, and then this a and q will go to the bottom. This is all thing is equal to dB, so a and q will goes to the bottom, and also we have 4 pi r square, 4 pi r square remaining. And from this one you can see this a and q and this a and q cancels each other. So finally we are I forgot to mention, this is the charge density, that is equal to I over a, that is equal to nq drift velocity, and this n is same as this one. This n represents the number of the charges, free charges available for unit volume, right? So that is this n. Now let's solve this one. Here we have mu naught I dl cross r divided by 4 pi r square. This is the Biot Savart law. and this is the final expression. I hope this helps. Thanks for watching.